What's going on, everybody? It's Mr. Olson's third hour class back with another video. Take it away, Mr. O.
Thanks, Alex. All right, we're going to finish up section 4 today in chapter 4 with graphing some sines and cosines again. These are known as sinusoids. That was Alex Strifka with the kind introduction there. Go ahead and take a second to read through example 6. We are going to write the function of a sinusoid that has certain criteria here, a minimum value that they give us and a maximum value. So we're going to do a little sketch here to start this out. Actually, these are not going to necessarily be the axes that we're drawing, so I'm not going to make them these big dark lines that make it look like it's the x and y axis. We know that this has a minimum value of 5 at x equals 0. So actually this one we can say is the y-axis. That's 5. So that is not the x-axis that you see up in the middle there. I'm just going to draw a light line through this guy too and a light line up here where the maximum is. Okay, so we have a minimum of 5 on the y-axis where x is 0. Nope. It's 5. Because this thing's been shifted. So we got to figure out where it's been shifted to. Maximum value is 25. So this is the line 25. This is 5 right here. And that maximum of 25 happens at x equals 32. So I'm just going to put a 32 here. And put that point there. All right, let's break down what we see here. What must be the midline? I'm going to move this 5 out here. What must be the midline of this function? If the minimum happens at 5, the maximum happens at 25. Why 15? You got to talk loud.
It's the middle between 25 and 5.
Yeah, find the average, right? If the numbers are goofy, add them up, divide by 2. I mean, if you can look at 5 and 25 and go, oh, the middle in between them is 15, that's awesome. But if the numbers are hard, add them up, divide by 2, you find the average. This is your k value. If the midline is 15, that's what it's been shifted up to. So that's our k value. K is 15 here. Okay, so the fact that 32 is where our maximum happens, does that mean that our period is 32?
No.
No. What is our period? 64. Let's write this here. This is a pretty important idea here that's going to pop up quite a bit. The distance from your minimum to your maximum, or from your max to your min, in any sinusoid is going to be half the period. So we know in this case here that half the period is 32, which means that the period is 64.
Would it be 64?
No, because it just says that, it doesn't say that this is 32 pi, just 32. So what we're going to end up having is a pi in our b value. So let's find our b value next. We know that b is 2 pi over the period, or in this case, 2 pi over 64, which is pi over 32. We could also say that b is pi over half the period if we're using this whole half the period thing, but I'll just use the one that we used in the last set of notes. So that's our b value, and like Ethan just brought up, we have a pi value in it because there is no pi in our value that's on the x-axis. So do we have everything that we need so far here to write this function? We know it's been shifted up 15. We know that the b value is pi over 32. What type of function is that, sine or cosine? If we want to...
Cosine.
I will throw my coffee mug at you. This is a cosine function with a negative a value. What is the amplitude? 10. But since we're saying this is a negative cosine graph, we have y equals negative 10 times the cosine of our b value, pi over 32, x. and it's been shifted up 15, so plus 15, and just to get rid of any ambiguity of what is inside that cosine, I think we should put parentheses there. Any questions on that at all? All right. Take a second to read through example 7. I'm going to start sketching kind of the same idea what we had before. This might not be the axes, but I'm at least making it the midline and kind of the starting axis for our function here. So we have high tide occurring at 9:36 a.m., low tide occurring at 3:48 p.m. How many hours have gone by between those? Well, actually, before we do that, let's turn those into decimals, because we're gonna let midnight be x equals 0. Okay, so as a decimal, so we can find out how many hours past midnight we are. 9:36 would be 12 goes into both of those, so we have 9 3/5, or 9.6 as a decimal. What about 3:48? 48/60ths. What does that simplify? Bless you. What does that simplify to? Why 15?
Because noon plus 3 hours, so 12 plus 3 is 15.
Yeah, because this is hours after midnight. So since this is PM, the 9:36 is 9.6, but then we are 15 hours to get to 3 p.m., 15 hours after midnight, and the 48/60th simplifies to 8/10. Okay. So then, let's go back up here. What is the distance between those two purple vertical lines that I have there? 6.2. 6.2 hours. That's half the period, because that's from a maximum to a minimum. So the period then is 12.4 hours. Okay. How about the midline? What do you think our midline is? What do you think that value is right there? 2.4? You can just find the average between the 0.7 and the 0.1, right? 0.8 divided by 2 is 0.4. All right, so here's where we're sitting. We've got this as our function. Does that look like a cosine, sine? What do you think would be easiest to write? Cosine, and positive too, right? So we've got, so far, y. Nope, let's use some useful variables. I'm going to use d for depth and t for time. So I'm calling my y-axis d, my x-axis t. What's the amplitude here? 0.3 times the cosine of. We don't have our b value yet. I'll come back to that in a second. I don't think we're going to have to shift this thing left to right, are we? Are we on the axis here? Is this the y-axis?
No.
No, it's not. How far do we have to shift this thing? 9.6 to the right. So we're going to have x minus 9.6. Okay, anybody find that b value yet? We know that b equals 2 pi over 12.4. b is then pi over 6.2. With all the work that we've done, we're going to be okay with having that decimal in the fraction. Do I need to shift it up or down at all? Up to our midline of 2.4. You know what made this problem much easier? Personally, I think sketching this helps out big time. Okay, we're going to do that in the next problem as well. Are we okay at this so far? Applying these to some application problems. All right, we got a Ferris wheel, 50 feet in diameter. Let's draw a Ferris wheel here. That's my Ferris wheel. I think I have a better one in my smart notebook here. That actually looks like a Ferris wheel. All right. Let's put our dimensions on here. The Ferris wheel is 50 feet in diameter. The center of the wheel is 30 feet above the ground. So this is 30. Okay, so here's what we're going to do. I'm going to draw a sketch of a graph right next to this Ferris wheel, kind of using the Ferris wheel as my guide. So I have my minimum at the minimum of the Ferris wheel, the maximum at the max, and then the midline right at the center. I think this helps out. Because right away we know that that midline is at 30. I'm just going to put my start and end point in one cycle. The midline's at 30. Okay, what about the amplitude? What do you think the amplitude is here? 25. That is the radius of the Ferris wheel. So we know the amplitude is 25 and that our max is at 55 and our minimum is at 5. So I'm just going to write some of this information out. A is 25. K we know is 30. We're going to shift this thing up to 30. Okay, how about the idea that it makes one revolution every 40 seconds? What is that really telling us? Period. Right? And really they're giving it to us as a frequency. One revolution every 40 seconds. That means that the period is 40 seconds. So B equals 2 pi over 40, or pi over 20. So we have A, we have B, we have K. I don't think we're going to need to shift this thing at all. Because it says, if the center of the wheel is 30 feet above the ground, how long after reaching the low point? So we're going to start at the low point. Is a rider 50 feet above the ground? So we're going to start at the low point and end at the low point. Hit the maximum halfway in between. And we know that this is 40 seconds here. Not sure if we want to put that maybe down there instead. 40 seconds. And then we have 0 seconds as our starting value then. Okay. But here's what our graph is going to look like. What type of graph do you think, or what type of function do you think is going to be easiest to use here then? Cosine. So I'm going to use h of t here equals, our amplitude is 25. We're going to use a cosine. Oh, what does it need to be though? Negative 25. Cosine of our b value was pi over 20 t. And we're going to shift this up 30. We don't need to shift it left or right because we're starting with that minimum value right at time 0. Now that's the function. What we're really looking for here is, where does this thing hit 50 feet? We want to know, actually, if we're using this as our x value down here, we want to know that value right there. So I think the easiest way to do this, since we haven't done anything with inverse functions yet, is to actually use our graphing calculator. Let's go ahead and put those two functions into our graphing calculator. Make sure you are in radians. Make sure you are in radians. You know why? Because that b value we found by taking 2 pi divided by b, not 360 over b. Go ahead, Drifka, we'll wait for you. Okay, so you've got I still have people that refuse to use their fraction template. Use your fraction template. It makes things way easier. Alpha, y equals, and then you have pi over 20 as your b value. After you get that typed in, make your window basically the same thing that we have in our sketch right there. Make your window the same thing that we have in our sketch right here. So I've got from 0 to 40, and I went by 10 so I could split it into fourths. And then for the y minimum, I went from 5 to 55. Now you could zoom out, obviously, so you could see more of the graph. But by doing this, you at least see that one cycle. Let me know if you need help with that window again. Make sure you're in radians. There's a Ferris wheel. I don't know. I think that's Nicolas Cage. I think we had Wager on there last year. It's too bad I don't have that. I don't have that either. It's too bad. There he is. It's good stuff.
Very nice.
Oops. All right. Find the intersection between those two. What did you end up finding? 15.9. Just going to run through that real quick here. Second trace gets you to that calculate menu for the graph. We want to find intersection number 5. It'll ask you about the two curves. Am I on the first curve? Yep. Am I on the second curve? Yep. It even color codes it for you. Want you to guess. I'm pretty darn close. Make sure you're doing the intersection on the left because of the way that the question is worded. Because of the way the question is worded, you want to find that first intersection. So there we have 15.9. So about 15.9 seconds after it hits the low point, you will be 50 feet off the ground. Any questions on that? We okay with the graph calculator?
Yep.
Okay, change your window. All right. So the last thing that we're going to put here, or look at here is, I think I grabbed, this actually might be one of your homework problems, but I grabbed number 54 out of the book. It says select a pair of functions that have identical graphs. I want you to do this without using a graphing calculator by what you know about these functions. If you look at the two parent functions, we have the two posters up there. If you took that sine function, huh?
You can't say A and C.
Yeah.
Can eliminate that.
Well, it can't be A and C. Right, okay, good. We've eliminated A and C. Okay, look at the sine function. If you shifted that pi over 2 to the left, it would be that graph right there. Right? Because right now, on the sine function, the maximum is right there. If we want to move that maximum over so that it's on the y-axis, we have to move it to the left. How do you know how far? Well, the sine function, I'm going to do in purple down here, the sine function we know starts at 0, 0. There's 2 pi, so there's pi over 2. Obviously, there's 3 pi over 2. So if we took this point and we shifted it left, pi over 2, we'd have the cosine function. In fact, let's just write, have it somewhere here, that if we shift sine left, pi over 2, we'll get cosine. Or in other words, cosine of x equals sine of x plus pi over 2. And we could go the other way. We could shift cosine right pi over 2 to get sine. So sine is equal to cosine shifted right by pi over 2. And we can use that idea to help. I mean, really, the selecting of two answers here is minimal compared to this idea. That's really what we want to talk about, that these sinusoidal functions, by shifting pi over 2 in one direction or the other, you can get the other function. So our answer here then, based off of this idea, is that A and B are identical. Questions?